Hi folks, I'm Darren. I won't bore you with details about me just yet, but first I want to ask a question, why? Why astrophotography? Perhaps it's something that really fascinates you. Maybe the night sky really grabs you. Maybe you just find it beautiful and you want to experience it. Everyone gets something different out of astrophotography. Myself, I really love being under the night sky, especially when I can be out there with other people. It's something that I find really engaging and rejuvenating, and that's what I get out of it. So I want you to keep that in mind. What's drawing you towards astrophotography? But regardless of what's drawing you, there's one thing that is just unavoidable. Astrophotography is better at night under a dark sky. So we're going to go to cleardarksky.com here, and this is a dark sky map. Here you can see the bright colors are not good areas for astrophotography, and the darker ones are better. Here, if we go out to all of Alberta, we can see that we actually have quite a lot of light pollution, but we are also blessed with a bunch of dark sky preserves, which are actually recognized nationally. And these are some of my favorite ones, Jasper in particular. But, I want to take you on a little bit of a journey. So let's hit the road and let's try and find some dark skies and, see if we can find some good photos to take. First, we're going to hit South Central Alberta, Drumheller. I always encourage you, especially if you have companions traveling with you, to find a place that gives you something interesting to do in the daytime, as well as something interesting to photograph at night. And here in Drumheller, we have the wonderful hoodoos. They make a great subject. And in the daytime, obviously the Royal Tyrrell is a fantastic place to visit. And these hoodoos are really interesting. You can find them in different places in the Badlands, but these are the hoodoos out in Drumheller. And here we can see we can use them in a bunch of different ways. If we go down the road a little bit, we can actually find ourselves in Dinosaur Provincial Park, another gorgeous place full of a ton of cool stuff to do, both in the daytime and at night. There is a ton of really great geology out there, some cool rock structures, and you can use them in really interesting ways. And I highly recommend getting out that way if you ever have the opportunity. But, I'm really partial to the mountains, so let's go see what else we can find. And everywhere in Alberta is, kind of within 3 or 4 hours of everywhere else, at least if you're coming from Edmonton, with the exception of up north. But we'll head to Abraham Lake, beautiful spot. You can do random camping there. If you go along the Icefields Parkway, there's a bunch of interesting spots to stop as well. And the night sky out there is just fabulous and fabulously dark. And you can get some really great views of the Milky Way. But, something's not quite right. Something feels like it's missing. So let's get back in the car. Let's hit the road again. And we'll go along the Icefields Parkway, see what else we can find. Now, this does actually represent a real trip I took last year. It was quite a busy couple of days, but we now find ourselves at something a little more striking, the Crowfoot Glacier. And this is a great spot if you're ever north of Lake Louise, but it's a little bright for astrophotography. So let's wait till nightfall and see what the sky can give us out here. And I can tell you from personal experience that the skies here are wonderful. This is a time lapse I took from that exact spot last year, and it was just the beautiful Milky Way above your head, the warm summer night. It was absolutely phenomenal. So if you are the type of person who is partial to that kind of adventure, I highly recommend just driving up and down the Icefields Parkway during the summer, spending a couple nights just at the side of the road, essentially, with your camera. And it can be just really, really a great experience. It's also fine during the day. I guess it's fine. But, it's the next morning. We've had an hour of sleep. Let's grab some coffee because we have a lot of work to do. I really always encourage people to plan your astrophotography so that you know what you're actually going for, in addition to doing some exploration so you can find some good compositions. You want to make the most use of your time out there. And this one I quite liked. Actually took my then 7-year-old daughter through a dark forest to the side of this lake in the middle of the night. And, Father of the Year. But the Milky Way isn't the only thing up there. This is actually the constellation Cygnus, which is an extension along the Milky Way. And it's rich with nebula and texture and all kinds of cool stuff. This is actually the California Nebula, the North American Nebula. And if we look at it in a different type of light, you see there's all kinds of detail and texture that you can bring out. So if that is of interest to you, please stick with me and we'll see what's up there. Now, before we dive into it deep, we're going to do a little bit of the minutia of the course itself, but I do want to hopefully welcome you to astrophotography. Who is this course for? If you just find astro stuff beautiful, if you are the type of person who's just fascinated by space, or if you're the type of person like me who just loves staying up till the early hours of the morning, this course could be for you. And one question that you might have for yourself is, what do I actually need for this course? Well, there are some things that you will need. Astrophotography is a little bit more of an advanced type of photography. For this course, you're going to need access to a DSLR or mirrorless camera. You're going to need the knowledge to actually use that camera in manual mode and know the balance between exposure, time, and aperture and ISO. A wide angle lens with a fast aperture is really handy, and a tripod is usually necessary, although I've made do with a rock once or twice myself. And if your camera has an internal intervalometer, or if you have a remote release, that'd be really useful. Hi, I'm Darren. I am bananas for space, basically. I'm a science communicator. I work and volunteer at a local observatory here in Edmonton. Public outreach is something that really drives me, and I love introducing people to the sky and getting as many people interested in that as possible. I really want to bring as many people into it as I can. My credentials hopefully speak for themselves. And I want you to know I'm not the first, best, most authentic, or most correct person out there. Astrophotography is art. There's no wrong way to make it, in my view. So I don't like having that kind of gatekeepy approach. But from this course, what can you expect to learn? Well, we're going to cover a number of things, including the basics of the night sky itself. Of course, the stars move, and we'll cover why and how they move and how that will affect your photography. There's also the fact that the sky changes throughout the year. It changes through the seasons, and that's something that you'll need to plan around. It also changes based on where you are. The view up here in Alberta is not the same if you were in Chile, for instance. And we'll roll all that together and show you how to find good dark skies, which can be just the best gift possible for an astrophotographer. And you might be asking yourself, well, I like the Milky Way, but what else can I see up there? Well, there's the sun. This particular image of the sun I took a few weeks ago using something called a hydrogen alpha telescope. It takes out almost all of the light, and it lets you see the surface of the sun. Now, this is a different view. This is a white light filter. It just takes out most of the light and shows you the sunspots. But that dot isn't a sunspot. That's actually the planet Mercury, which did what's called a transit across the sun a few years ago. It's really lucky to get that shot. And this is a different type of white light filter, but you can see it is showing you those sunspots. But you'll notice there's something else in the frame. That's actually the moon, because this is a solar eclipse. Now, mark your calendars. April of 2024, there's going to be a total solar eclipse going over North America. A lot of the states in Eastern Canada, you might want to make it out and see it. It's not the only type of eclipse, however, because we also have lunar eclipses. This is when the Earth passes between the full moon and the sun and casts its shadow over the moon. That red color is actually light reflected from Earth's night side back to the moon and then back to Earth. So we're seeing the light reflected from Earth, essentially, and it's got its own charm for sure. If that's not quite your thing, we also do have classic moon. There's some people out here that are just enraptured with it, and that's all they want to take photos of, and that's great. That line where the night meets the light, that's called the terminator, and you get some really great texture there, some really good contrast. But that's not the only way to take a photo of the moon. We also have some more fun ways. I might be accused of being a bit cliche here, but I love hanging out with friends. These two were really good sports, and there's all kinds of fun ways that you can experience astrophotography. This is actually a video of the moon, and you can use a video to make a really detailed photo of the moon, but we're not interested in that for this particular part, because you might notice there's something else there. That's the planet Mars. Planetary photography is something that you can easily do from your backyard, in addition to different types of solar system objects, such as comets. This is a comet from a few years ago. You might have heard something about a green comet recently. Well, a lot of comets are green. This one didn't have a tail, so I made the frame spin to make it interesting. But this comet did have a tail, and you might recognize this one from the summer of 2020. It's a visual comet. It was beautiful. I don't quite remember the name, pardon me, but yeah, they're fantastic. And when a comet goes through the solar system, it leaves a dust trail. And if Earth goes through that dust trail, it can cause meteor showers, such as the Geminids, as those little specks of dust blaze through the atmosphere. But anytime you take a photo of space, you are going to inevitably get a constellation. This is the constellation of Orion, actually. And you can see there's a lot going on here. There's a lot of color. There's a lot of texture when photographed correctly. But you can just keep zooming in and see more and more of it. Here we have the Great Nebula in Orion and the Running Man Nebula. And these are called emission nebula because they are emitting light. They're actually stellar nurseries that are giving birth to stars. And as those stars heat the gas up, the gas glows in this beautiful light. So that pink that you'll see, or the magenta or red, is often called hydrogen alpha emission. That's hydrogen that's releasing light. But there are different types of atoms and molecules out there that are emitting their own. This is a different object. This is actually called a planetary nebula. And this is really interesting. It has nothing to do with planets, but it's actually the end stages of a star's life, such as our own star. In the middle is a white dwarf. It's about the size of a planet. It's extremely hot. It's the core of its star. And all that stuff around the outside is actually the layers that it's puffed off. And it's heating them up from within because it's so hot. It's the core of a star, and they're glowing in space. Stars come in a wide range of clusters as well. This is the open cluster called the Pleiades. It's a group of stars that were born together in one of those stellar nurseries, and now they're slowly spreading apart. The blue, ghostly blue, is a reflection nebula. They're passing through and behind some dust, and while they're not heating it up, their light is going through it, and you're experiencing the same type of thing that you would experience with say, the sky. This is a globular cluster. This is a tighter collection of stars, a lot of stars in a tiny little ball around the same age, almost like a mini galaxy, but it's not a mini galaxy. This, however, this is the Small Magellanic Cloud, And this here is the Large Magellanic Cloud. These are dwarf galaxies that actually orbit the Milky Way and will one day probably become part of the Milky Way. And there's all kinds of galaxies out there, spiral galaxies, elliptical galaxies, and some really well-known ones, such as the Andromeda Galaxy. This particular galaxy is utterly huge. It's so huge it makes its way into a lot of photos you don't really mean to catch it in, such as this photo of the aurora from last summer. The aurora is the green part. These pink tendrils are actually Steve. It's a phenomenon that was coined by the Alberta Aurora Chasers Facebook group, and we'll actually explain why it's called Steve in the course itself. But the stars are also moving all the time, obviously, and we can create really cool star trail images and time lapses. So there's just so much up there that you can bring home and just with a normal camera. But of course, I'm forgetting something, because there's also the Milky Way, the thing that everyone tends to think of when they think of astrophotography, and something that we are going to teach you how to take a photo of at the end of this presentation. So please stick around. But before we do that, we will talk a little bit more about what we're actually going to touch on in this presentation, or rather in the course itself. One of the things we're going to address is a little light science of the science of light, forgive the pun, because if you know how light works, you can make the best use of it. We'll talk about why things are colored the way they are. I alluded to some of this already with my comments about emission nebula, but depending on where the light's coming from and how it's interacting with the interstellar medium, you get different colors and different levels of faintness or brightness. The Orion Nebula is really, really bright. It's so bright you can actually see it with your unaided eye when Orion is up in the wintertime. It looks like a star, a fuzzy star, but there's so much going on there. And it's just fascinating, at least to me, and hopefully to you. And you'll see these images from the Hubble quite often. This is the Ring Nebula, as we mentioned earlier, but these actually are taken in false color in different wavelengths that you can't maybe see visually all the time. But another interesting thing about this nebula is that it's 1,400 light years away. That's 1,400 years between the light that left that nebula and the time that it was captured by Hubble sensor. So essentially, whenever you're doing astrophotography, you're time traveling, which I think is just mind-blowing. Now, I love air. It's good to breathe, it's great, but unfortunately for astrophotography, air can cause some issues. Here we see this video of the moon again, and you see it's kind of wibble wobbling back and forth. That's because air acts as a lens and actually will twist and bend light. That's actually the reason stars twinkle, is because they're little pinpoints of light and they're trying to make it through the atmosphere, but it's moving that light all over. So there are some considerations, and we'll talk about those in the course to make sure that you can make the most of your time and know the best approach to maybe take a photo of Mars or the moon, for instance. But before we do that, there are some ins and outs to cover. There's a lot that goes into astrophotography. It's quite a bit different than terrestrial photography. I often think of it as being kind of a parallel to terrestrial photography. And it's not just taking photos in the dark. It's not as simple as that. There's a bunch of unique considerations that you really have to have a handle on, and we will discuss those in the course. There's specialized techniques, equipment, there's specialized software, a lot of it community built actually, that can be used. And essentially, we went through all the different things that you can actually take pictures of. There are really tailored approaches that will give you the best results for taking a photo of the moon, but not a nebula. And we will do our best to demystify these for you, set you up for success. We'll teach you the right gear for the job so that you don't waste a lot of time trying to use something for something that you can't actually accomplish. And we'll also teach you, importantly, how to navigate the night sky using apps. Specifically, I'm not of the old school frame of mind that you have to learn to do it by hand with a piece of paper and binoculars. We'll teach you how to find your way around so that you can find what you really want to take photos of. And you can get down to the business of doing photography, which I think is the most important thing. Now, there is cameras useful for photography. Not everyone's a gearhead, but it is good to know how they work, because there's a couple of things that you'll need to know to get the most out of your camera or any camera that you might find yourself with in the future. There's some core concepts that you can transfer from camera to camera that are brand non-specific and that type of thing. So we'll go through that. Pardon me. We'll also cover the different types of cameras, because you do have your traditional DSLR mirrorless camera. You might have also heard of something called a modified camera. You might have also heard or seen of an astronomy camera, which honestly bears some resemblance to a coffee cup or a can of soda. And these are all different things that we'll go through and make sure you know what's necessary and what's not. But ultimately, the best camera is the one that you have now, and you'll be given the skills and the knowledge to know what your best next camera may be, depending on what direction your astro journey ends up taking you, because you might not need the same one for the Milky Way that you might need for planets, for instance. And that is something that we'll make sure that you know, so that you can really go out into the universe unaided. And another thing that people kind of get stuck on is camera settings, and we will go through those. Do not fret. We'll make sure that they're easy to understand. It's not really all that complicated. Learning to balance exposure is really important. There's a tug of war between shutter speed, aperture, and ISO, and that can help you maximize the exposure you can get. But if the sky is just moving too quick for what you want to do, we'll teach you the methods that you can use to actually hold the sky still. Hint, it's equipment. The answer in astrophotography is often gear, unfortunately, but luckily, these are not things that are unattainable to regular mortals such as ourselves. We'll also talk about optics, because there's all kinds of different optics, and we won't drown you with a bunch of technical jargon and stuff, but we will touch a bit on how they actually work and a bit on the different types of optics that are used and useful for astrophotography. There's all different types, from your camera lens on your camera right now to big giant telescopes that look like a trash can on a tripod. So we'll go through that and let you know what's what, and teach you what's right for the job that you want to do. And it's not always the most expensive thing. This is not a joke. I made this image using lenses I got at Value Village that were made in the 70s. They were fantastic. So sometimes you don't always need the most expensive thing, but depending on what you're taking a photo of, the optic you have and the camera you have, there might be an optimal combination there. So we'll go over that. And we'll also teach you about optical aberrations, so that you can know for yourself what is the best type of lens for you for what you're looking to do, or the best telescope maybe, if that ends up being what you want. And I alluded to it earlier, but sky tracking is something we'll go through. The stars are moving from our perspective, and it is something that we have to deal with. And there is really not a lot you can do with that other than have a faster aperture or hold the sky still. And using a star tracker in a lot of cases will be more than enough for most people. And this simply follows the sky. We'll teach you exactly how they work and show you examples. So hopefully that will seem a little less mysterious, but it really can make a huge difference in the images you're able to create. Getting that extra exposure is so helpful. Sometimes it's a necessity. If your object is really small or really faint, you'll need to do a longer exposure and probably with a longer focal length. And that will most likely necessitate tracking. But if you're doing a Milky Way photo, honestly, a wide enough lens and a tripod is all you need. You don't need, maybe don't want to do any tracking. So fear not, and put the wallet away for now. We'll make sure you have a handle on what works best for what situation, so that you are really set up, not only in the present to start your astrophotography journey, but also to really have a good direction for the future, to make sure that you know where you need to be or where you are, essentially, if you're happy there. And this is a bit ironic because this is going to be the shortest part of the presentation, but post-processing is possibly where you're going to spend the bulk of your time to get an astrophoto from start to finish. There's tons of different software out there that can help you tease out, very faint, let's say, nebula or detail that you couldn't see in the Milky Way. And some are paid. There's one in particular that's quite expensive called PixInsight. There's some are subscription, for instance, if you rent Photoshop and Lightroom like I do, and some are free. There's really good free options out there as well. There's a lot of open source software that can be used, and there's a lot of that for astrophotography specifically. So you've got a lot of options, and we're going to delve into that in the class and really give you a handle on how to take a photo from, maybe a dark fuzzy thing to a, really bright, beautiful photo. But for now, we're going to do a little bit of practical stuff because it's Milky Way season. You're going to miss it if we don't address it now. So Milky Way season and your view of the Milky Way depends on where you're located. In Alberta, we're really high north. We're, Edmonton's 53 degrees north. So this does two things. We don't have a great view of the core of the Milky Way always. And we also have bright summer nights around the solstice. You just don't get actually true dark. So it's really something that you have to plan around if you want that Milky Way photo. And luckily, late July and August is a great time, just right around the corner. So I want to give you some of the skills, if you don't have them, to go out there and do it. So grab your camera and don't worry about the camera that you have. Again, the best camera is the one that you have. For instance, here's my first Milky Way photo. I can't express in words how excited I felt and how in awe I was when I saw this appear on the back of the camera. Not quite like this. This took a little bit of adjusting, but this is the camera I used. I used a cinema fisheye lens with a slow aperture and a Canon Rebel T3i from 2012. But you know what? It just filled me up with so much excitement, and it really helped set me on the path to doing astrophotography. And here, I guess, now teaching you about it, which is phenomenal. So step one, you're going to get your camera and you're going to get the widest lens rather you have, or that you can source, and set the aperture as wide as possible. Step two is you're going to have to find a dark place to take a photo, optimal photo. So you're also going to want to make sure that there's no towns or cities south of you. You always want a clear view to the south with no light pollution when you're doing astrophotography. So we're going to go back to cleardarksky.com and we're going to look at the light pollution map. Blue's good, gray's better. Even the green, you can deal with green. Elk Island is kind of green. So there's places within an hour, hour and a half drive of Edmonton, for instance, less if you're down near Calgary. So you're going to choose a place, but you're also going to need to know what the best time to go there is. So that's going to be something that's really important. So we're going to go to timeanddate.com. They've got a lot of great tools. Go to sun and moon and choose the sun calculator. And you can actually write your city. If you're Edmonton, you want to get something at that latitude, or you can actually open the map and choose an exact place on the map. So let's say you've chosen a nice dark spot. Maybe your family has a farm out of town or something like that. You can go in there and choose exactly that spot. For now, we're going to do Stoughton Lake over in Elk Island, and that's a local dark sky preserve. And if we look down here, we actually see the sky brightness chart. And essentially, it will tell you how much dark, twilight, etc., daylight you have on the day. Unfortunately, right now, there's no true dark. But if we go into early August, in about a month, we get a smidge, like an hour or two. And as you approach the fall and the winter, obviously the days get shorter and the nights get longer, and we finally get some of that good, true dark. And as I mentioned before, the solstice is a really, unfortunately, bad time up here. It never gets true dark. It's, very bright, and which is unfortunate. But next thing we're going to do is we're going to go to stellarium-web.org, and this is a free planetarium app, because we want to see, okay, we know when it's going to be dark, but at our location and during the date and time, we want to know where the Milky Way is going to be approximately in the sky. If it's, dark at 2 a.m., but the Milky Way is already set or something like that, then it won't really be that useful. So you can choose your date and your time, and you'll see the sky changes. There's a little slider there, and actually will move the sky as the time flows. That slider actually also, you'll notice it's got the same kind of color coding from the time and date website. That dark portion in the middle is when it'll be darkest, and the light portion's self-explanatory. So here we can choose maybe early August. You know what? It's around midnight. There's not really a lot of dark to be had. We can't really get that true dark. So maybe it's not the best time to go. Don't rush out there right after the presentation, essentially. But if we wait a couple days or a week or two, now we can start to get that, sliver of true dark at night. And you can see actually when it's going to be dark, where the Milky Way is going to be. This is going to really help you plan to take your photo. So this is a really useful web app. They also have mobile versions as well. The web is free. I'm not sure if the mobile ones are. I suspect they may be, but I check it out. So now we know where to find dark skies. We know when the sky is going to be dark, and we know where the Milky Way is going to be oriented during that time. So there's only a couple other things we need to do. Of course, step 4, we need to figure out what the sky conditions are going to be. Clouds and unfortunately smoke are a real reality, especially here in Alberta. So we're going to go back to cleardarksky.com. And if you click on the clear sky charts, you're going to get what looks like a pretty messy graph, or something maybe that you've seen before, depending on how into astro you are. But here, importantly, it will tell you the expected cloud cover, and you can hover over any of these squares to get a little bit more information. But on a couple of days ahead of time, and any time in between the present and then, and that's an hourly forecast essentially. Cloud cover, transparency, and seeing are something we'll cover in the course. These are different things that will affect your ability to actually take photos of the sky. And unfortunately, well, also we have the sky darkness again, but unfortunately we've got that smoke. And this is going to give a estimation of that for you. And if you scroll down on this page, you will get to a place where you can choose your location. So we'll choose Edmonton, and we'll kind of see what it's looking like this week. And there's a couple of different locations that you can choose, but if you're going to be around Edmonton proper and you're curious, this is where we're going to be for the next few days. Unfortunately, it's going to be smoky, folks. That is unfortunate, but luckily there's not going to be a lot of clouds. There's also a smoke map that you can take a look at, and it will give you a visual representation of where and how bad the smoke is. And unfortunately, again, currently Alberta is just inundated in smoke. I believe there's not a sort of free part of the province anywhere that's not covered at least under medium smoke, if not heavy. I sincerely hope that this doesn't continue for the rest of the summer, but I wish you luck. I hope that you can find a smoke-free spot. Saskatchewan, northern Saskatchewan is looking pretty good right now. And if we come back to the website here, there's a bunch of other useful information, such as aurora forecasts and other types of things. And those are all really useful, although usually that cloud cover is going to be one of your primary concerns. So now we can get on to step 5. Covered where the sky is, dark, what the best time to go is. We'll know how to watch the forecast, but camera settings are something that are going to be important. They're going to be different for everybody, but statistically, there's a good chance you've got a Canon DSLR, so I'll use that as the example, although this is universal. So first, you're going to want to set your lens's aperture as wide as possible. f2.8 is great, faster is better. Your shutter speed should be around 20 seconds, and you can try auto white balance or daylight white balance and see kind of how that works. It doesn't really matter though, because I really want you to shoot in RAW so that you get those editable images. And if you don't have a remote or an app or an intervalometer, you can actually set like a 2-second timer on a lot of cameras. The ISO, you're going to want to set to whatever gives you a decent exposure on the back of the camera, and you're going to focus in live view. So take a few test images and punch in and look at the stars and see if they're showing up round. You want them to be as round as possible. That means everything's good. It also possibly means that you can increase the duration of your shot. So maybe 25, maybe 30 seconds. That will let you lower the ISO, which will actually give you less noise in your images, give you a cleaner image. However, if your stars look like this, if they start to stretch out, that means your shutter speed is too long. You have to shorten it. And that might also mean that you have to increase the ISO to compensate for that reduced exposure. So step 6, we know how to take the photo, we know where, we know when. Composition. Composition is something that you should really think about in any photography, but also in astrophotography. If we look at my first photo, it's really clear that my goal was just to get as much of the Milky Way in the frame as possible. I was actually using a fisheye lens, so I almost got 120 degrees of the Milky Way. Now that was good, but a few days later, I started to think a little bit more about how to make the photo more interesting, how I could make it a little bit more dynamic, how I could make it just a better overall photo. And that's something that I've continued doing, and I always encourage people to do. Think about not just getting the thing, like, oh, the Milky Way is cool, I got to get the Milky Way, but how to incorporate the Milky Way into the whole photo. And I'll be the first to admit, I'm far from perfect. I don't have a gallery full of my photos, but I do try and bring some extra visual interest in there. And that will actually help differentiate your photos from other people's photos. You're seeing it in a certain way. So I really encourage you to do that. Give a bit of a focus on that composition. So with any luck, you now have the makings of a great photo, or at least in a few weeks. The next step will be to do post-processing to really make it pop. I use a combination personally of Adobe Photoshop and Lightroom and some other apps, but you don't have to, spend a lot of money. There are some free ones out there, and I look forward to telling you all about that in astrophotography.